Okay, let's try to extrude this little guy. This is a virgin PLA, and I colored it myself with powdered colorant that I bought from Amazon, and I hope it's not gonna clog the nozzle. We'll see. I already poured some. Slow down. That doesn't sound good. I think some pieces are melted too early, so I'm going to reduce the temperature a lot. Wait until it cools down. Okay, we have flow now, so I think it needs a little bit higher temperatures because of the additive that I add, but I adopted because it was extruding fine before. Maybe there's still some PETG leftovers inside the barrel, because I'm trying to extrude PLA right now. So let's wait a few more minutes until the color comes out, and we'll see. For now I'm going slow because I don't want to stall the motor. So right now I'm only trying the virgin materials, not the recycled ones, because I don't have any properly shredded recycled material yet, because I tried some recycled PETG, but it couldn't be able to extrude for some reason. I think it might be an issue with the feeding mechanism. I'm gonna add some vibration motor over here to vibrate the pellets to avoid any rat holing or bridging structures. It might causing some feeding issues. Okay. Oh, we see some color here. All right. It'll take a while until the colored material properly extrudes. Okay, now it's, I think the motor is now working much more easier because I can tell it's extruding faster. Let's try to increase the speed slowly. Because PLA likes fast speeds. Okay, we are getting the ampere reading is our cue here. If there's if the motor is working too hard or not. Maybe we can increase the temperatures a little bit more. Okay, looking good. Well, let's spool it and see if we can achieve 175. It's a little bit tricky to push it down here. Alright. And start the EMG. Let's adjust these guys. I think I can increase the spread a little bit more. More. Okay. Let's start spooling. So I'm not gonna use the guide of the filament because it usually messes up the things. Instead, I'm gonna just spool it as it is. Sometimes you need to agitate the pellets because you can't see from here, but there might be some spaced out areas. It's called rat holing or bridging that might disturb the flow and cause the uneven extrusion. So I'm gonna add vibration motors that I mentioned earlier. It is the reason. Okay, tolerances are a little bit better now. Can even completely turn off the cooling. Can also disturb the diameter. I have seen it before. This material, this PLA, doesn't like too much cooling, or at least very fast cooling. So I turn it off and let it cool by itself. So it's still a little bit hot, but that is okay. Oh yeah, as soon as we turn off the cooling, you can see that it immediately changes the diameter. So I'm gonna slow down the puller. Okay. Well, seems like we have a nice filament going on here. Alright. I think I can safely say that it's okay to use those do-it-yourself colorant kits that you can buy from Amazon cheaply. People usually use them to color their soaps, candles and such stuff. This is, I think, this one includes a little bit mica powder in there, like a sparkly thing. But don't overdo it, because there is only less than 1 gram of powder in 200 grams of PLA. Because if you add too much, you may not extrude at all easily. And that small amount is actually really enough to get a nice color. Of course you can experiment it, but alright, next thing I'm gonna do is gonna print something out of it. So I'm gonna let you to decide what should I print with this filament. It's almost finished. There's almost no material left in here. I'm just gonna wait a little bit longer until the reader tells me that the filament gets thinner, because it's also still gonna keep extrude a little bit more even when the hopper is going to seems to be fully empty. And we have a nice roll of pink filament here. So guys, tell me, what should I print with it? Okay, we are almost getting there. I can already see that the current material is going below 1.4. Actually, it's safer to run the machine on around like 1.2, 1.1 amperes, because the limit is about like 1.7 ampere. This is by the current that the stepper driver currently consumes to drive the motor. It constantly changes to adjust the torque of the stepper. Normally extruder machines are using actually brushless DC motors, but I choose stepper because it has much more control over the RPM. It can constantly drive at the same RPM compared to brushless DC motors. And this one actually is much more cheaper than to get a brushless DC motor, because with the brushless DC motor it's like 2 to 3 times more expensive to get about the same power from the stepper motor. There are some tricks to use it, especially on very low RPMs like 1 or 2, because on these RPM levels the maximum current limit of the motor itself drops. I don't know why, because I'm not expert on motors, but you need to be really careful about the current readings. Okay, the hopper is empty, but the filament is still coming out, and the current meter is still dropping. So I'm just need to keep my eye on my measuring device. And this is a very simple puller that I modeled on Autodesk. It's actually the BMG extruder that you can buy very cheap on online, like 10, 15, 20 bucks. And this is a stepper driver, that stepper controller actually, that driver builds it itself, so you don't need a separate driver also to drive this stepper motor. Just goes wires in there. Okay, I think it's safe to stop here. Let's roll this guy. Cut the cord, turn this off. Yep, almost nothing coming out right now, and the current is about 1 ampere, and the motor actually runs on 48 volt DC to get out more torque from it. So I choose 48 volts. instead of 24 for this reason. So I'm gonna wait until the extrusion totally stops, because it's better to leave the barrel empty for the next extrusion as much as possible. But also don't let the machine idling. Actually, let the motor idling for too much, maybe 5 minutes tops. If there's no material coming out of it, turn it off immediately. Because if you don't turn it off, you may wear out the screw. Oh, by the way, the colorant that I use is food safe because it's for soap making. So I just did a food safe PLA at home. And the PLA that I use is free of additives because it's pure PLA. It's the brand is Total Corbion. I think I can turn off the motor now. That's it. We can turn it off this one also. And let's see our filament up close. Yeah, I know. I should also build a better spooler machine. This one is still okay, considering the price. It's very cheap. It's filament, so you can get it from Polystruder webpage. Anyway, nice looking. Yes, no visible bubbling, no visible dirt or any other thing. Okay, perfect. Okay guys, that's it. See you on next video.